Hi Madhu, good evening.
Good evening. How are you doing, Nasir?
I'm doing good, thank you.
Good,
So
good.
now with us Madhusudan Rapole. He's the founder and CEO of Oorja Energy Engineering Services. Madhu, welcome once again. So Oorja specializes in something that very few companies in the country do. He has been focusing, Madhu and his team have been focusing on sustainable cooling for sustainable heating and cooling, and predominantly sustainable cooling for the greater part of a decade. So it's a pleasure to welcome Madhu once again for this talk. And we are hoping that, over the next 10 minutes or so, we get some pretty interesting insights from him on what he has been doing. Welcome once again, Madhu.
Thank you. Thank you, Nasir, for having me.
So, Madhu, today I want to focus on a particular aspect of what you guys are doing, and that has to do with building cooling, what we traditionally define as air conditioning. Yeah, so it could be the small air conditioners for residences, or maybe the large chillers for large buildings. I have a few questions for you, and I would really like you to tell us, based on your experience, where we are in each of these questions. The first is,
Sure.
we all know that, as a country, India is going to be one of the largest growth stories for cooling, building cooling and air conditioning, right? But
Yes.
what numbers are we really talking about? Do we have some numbers on this in terms of percentages, in terms of units, in terms of kilowatt hours? Can we have some numbers from you on this?
Sure, sure. I mean, the biggest number that we should be aware of is we are set to become world's largest consumer of electricity in next 2 decades or so for cooling. And this is according to International Energy Agency, and leaving China and US far behind. And today we are, and see this from a context where we are, the air conditioning penetration, meaning number of households using air conditioning, is less than 10% today in India. And for a comparison, Japan is about 90%, US is about 90%. China also is somewhere around 70% right now, I guess. Now, so you can see, now it seems to be a big gap right now, but reason why we will become this biggest consumer of electricity for cooling are actually pretty obvious if you see. When we leapfrog from our current position of the fifth largest economy to third or maybe even second largest economy, we would be probably the first developed country that is primarily tropical in nature. Okay. All developed economies so far are mostly above the Tropic of Cancer, right? Which is, temperate climates. So let me illustrate this with an example. So if you take, let's say, a 2,000 square feet office in, say, Paris, that would use, say, about 4 tons of cooling. The same 2,000 square feet space in India, in, say, Chennai, would use 10 to 12 tons of cooling. So our cooling requirement per square foot is more. The number of hours we use is more, 600 hours maybe on an average in Paris versus 2,500 hours. And lastly, we end up using more energy per ton of cooling we use when compared to these temperate climates. So if you put it all together, along with our increasing affluence and warming climate, there's absolutely no doubt that we will be using a good chunk. I mean, and some estimates are as high as 40 to 45% of our electricity production at peak, when there's a peak demand. So we will use 40 to 45% of the generated capacity just for cooling at peak, right?
So that's going to be pretty massive. Yeah, that's going to be pretty massive. As you said,
I mean,
we're talking about a large country having just 10% penetration right now and going to 45%. 30%, even 20% is doubling that. And on top of that, the amount of cooling each of these guys will require will be more than what a European country will. So that's in terms of the total energy required, additional energy required, it's going to be massive. So essentially, you're predicting that over the next 10, 15, 20, 30 years, the delta in energy that is required for cooling is going to be a significant portion of the entire delta in energy that the country is going to witness.
Absolutely.
So let me go to the next question. Maybe whatever you said isn't exactly news to many, even though some of the facts you gave, probably the comparison between tropics and the rest of the world, rest of the developed world, that's pretty interesting. What solutions do we have now? Do we just have to rely on better and better air conditioners? Or do we have other solutions? Better and better air conditioners, better and better chillers? Is that what we are talking about? Or do we have something else on the horizon?
I would say, first and foremost, we have to make the buildings efficient. And when we say we have to make buildings efficient, there are two parts to it. Obviously, people like architects play a role where they can make buildings which are not just rectangular glass boxes which trap energy and make them literally greenhouses, right?
Yes.
Requiring more and more air conditioning. So there's a large part architects can play, having more shading devices. Somehow protecting a simple thing of protecting a building from direct solar radiation, right? There are many tricks that architects can use in terms of passive cooling. That is what I would suggest one should do first. Whatever you can do to passively cool a building, one should do that because it doesn't consume any energy. Thereafter, I would say the job of engineers like us starts where now we start looking into what is my lowest cost of energy to provide a ton of cooling, or how do I provide that. So do you know how old is the current air conditioning technology? How old, when the technology that we are using, when do you think it was invented?
I don't know, but I
Yes.
can make a guess. 50 years, 60 years?
Well, more than 100 years ago.
Wow.
Basically, it's the same technology. The technology was invented for making ice. And we
Okay.
said, hey, if we can make ice, this was more than 150 years ago. And then we said, hey, if it is cooling, why don't we use it to cool buildings?
Yeah.
And we have continued the same way for past 150 years.
Hmm.
We moved from what, 1G that we used to use in late 90s to 5G, and we are talking about 6G in 20 years. So there's nothing that has changed. So what we are seeing now, only now, when things are coming to this force, where more and more technological innovations in this space. We specifically work in something called radiant cooling, where we cool the building structure instead of. So what we do today is allow the heat inside and then use energy guzzling equipment like air conditioner to push this heat out. Cooling is nothing but taking the heat out, right? So with radiant cooling, we do it more efficiently, where we don't let the heat in and remove it from the structure itself. This we have implemented all across the country, can save anywhere from 30 to 50% depending on what you're comparing with. A version of this we call structure cooling is what we implement, which is which uses even less energy, about 90% or so, not giving the same comfort. And the reason why I say 90% is a good number of buildings in India do not require the Western standard of 24 degrees, 50% RH kind of a comfort. There are buildings like public schools, there are railway stations, bus stations. As we become a developed country, we need to be more egalitarian. We can't say you go to an airport, you will get an air conditioned space. Hard luck if you're traveling by train or bus, right? You need to provide comfort. So structure cooling that we do is primarily looking at public infrastructure, which has been so far been neglected. If you're in Chennai, you go to Coimbatore. I mean, there's no provision for cooling, not even fans actually. I mean, that is not how we will become a developed country or a third largest economy in the world. So, but we need to provide cooling at a very low cost, and that's what things like structured cooling allow us to do. There are other technologies that we have been traditionally using, like evaporative cooling. We do multi-stage evaporative cooling now, so that with the same old technology of desert coolers, we can now get lower temperatures. We are also moving towards where we say, why not use the wastewater? Okay, because water-based cooling gives more efficiency. Treat the wastewater and use it. So these are some of the technologies I believe will gain more and more acceptance.
So the last question to you, Madhu. It's exciting, yeah. I mean, lots of technologies you're talking about, but each of these probably is at a different stage of commercialization and scaling. So, assuming the top two or three out of these, be it radiant cooling, structure cooling, the top two or three, if we pick them up, and let's say they provide a 50% efficiency gain over the conventional in some way or the other, what is needed to scale these? Because
I think policy levers can work, really do wonders. Government had already mandated energy conservation building code in some states, and it's now moving towards energy conservation sustainability building code. All it needs, intention is good, the code is good. All it needs is more teeth to implement it. Commercial buildings about 2 lakh square feet, I have to adhere to it. So giving more teeth in terms of its implementation, right, would definitely scale up implementation of all these technologies. Other thing could be a tariff structure that encourages efficiency, like maybe a higher tariff beyond a certain kilowatt hour consumption, which clearly indicates that higher usage of air conditioning. Okay. Of course, awareness not just among the consumers, but more awareness among the influencers like architects, HVAC consultants is very critical. And I think the biggest difference would be somehow if people who are taking these decisions to build these buildings, today the incentives are disaligned. A builder has no incentive to put efficient equipment for the occupants who are the beneficiaries. So in some ways, if there are incentives for the builders if they build more efficient buildings.
thank you, Madhu. Thank you very much for your insights. All the very best.
Thank you, Nasi. Thanks again for having me.